In Lesson 5.3, you're going to be solving multi-step inequalities, and you'll solve linear inequalities involving more than one operation, and you'll also solve linear inequalities involving the distributive property. In example 1, you have a multi-step inequality in the form of a story problem. Notice that the story problem can be translated into an inequality, and then you can solve it like normal to find the answer. For our guided practice problem, I'm going to start by identifying what my variable is. In this case, the price per flyer. It asks in the question, what does the print shop charge for each flyer? So that's my clue what I'm trying to solve for. So if I did know the price of the flyer X, I would want to multiply that by 400 because it's looking to print 400 flyers. Then I want to add in the $3.50 setup fee, and I want to make sure that I'm coming in less than the competition. So actually it should just be less than $35.50. When I subtract $3.50 from both sides, I get 400x is equal to $32. And when I divide both sides by 400, I find out that the price per flyer has to be less than 8 cents. For example 2, we're going to do some more multi-step inequalities and paying attention to that negative coefficient. And that negative number is going to change the direction of the inequality symbol. So for the first guided practice problem 2a, 23 is greater than or equal to 10 minus 2w. The first thing I'm going to do is subtract 10 from both sides and get 13 is greater than or equal to negative 2w. When I divide by negative 2 on both sides, I'm going to get negative 13 halves is less than or equal to w. And I can rewrite that as negative 6.5 is less than or equal to w. Or, in my case, I like to have the variable on the left. W is greater than or equal to negative 6.5. Notice that that's a closed circle at negative 6.5, and we're going in the direction greater than to the right. The solution set embraces W such that W is greater than or equal to negative 6.5. In 2b, 43 is greater than negative 4y plus 11. If I subtract 11, I get 32 is greater than negative 4y. When I divide by negative 4, I get negative 8 is less than y. Because I divided by a negative, I'm going to flip that inequality sign. And if I rewrite that with the variable on the left, I get y is greater than negative 8. That is an open circle at negative 8 on the number line with an arrow going to the right. And let's just double check an answer here. Let's put the number 0 in for our inequality variable here. Negative 4 times 0 is 0. 0 plus 11 is 11. 43 is greater than 11. In example 3, we're going to get more practice with writing and then solving an inequality. Notice that in the problem we can translate that to numbers and symbols and inequality symbols. All of those things are important skills in being able to translate from words into a problem that we can solve. So for the example, guided practice 3, we're going to write 2 more than half of a number is greater than 27. What pops out of me right away is greater than 27, so I know that that's going to look like that. And then 2 more than, so that would be plus 2, and half of a number. So I could write that as 0.5x or 1/2 x. Either one of those would be acceptable. In order to solve that inequality then, I'm going to subtract 2 from both sides, leaving me with, let me come over here, 1/2 x is greater than 25. To isolate the variable x, we're going to multiply by the reciprocal, 2 over 1, multiply by 2 over 1, and I get x is greater than 50. And in solution set notation, I would do the brace, and I'd say x such that x is greater than 50. If I was asked to graph that on a number line, that would be an open circle at 50 with an arrow going to the right. Example 4, we're going to be looking at solving multi-step inequalities by using the distributive property. Remember that set of parentheses there indicates that we need to distribute what's out front, in this case the 4. And then after that we can continue with our steps, including getting the variables to the same side, combining like terms, and then isolating that variable. At the bottom of page 299, we have 2 guided practice problems. I'll start with 4a. When you distribute the 6 to the 5z and the negative 3, you get 30z minus 18, less than or equal to 36z. I'm going to subtract 30z from both sides of the inequality sign. And don't forget that negative sign right there. That comes down with the 18. So negative 18 is less than or equal to 6z. When I divide both sides by 6, I am left with negative 3 is less than or equal to z, or I can rewrite that as z is greater than or equal to negative 3. In solution set notation, that would be braces z such that z is greater than or equal to negative 3. Just wanted to point out here this watch out bubble, the distributive property. If a negative number is multiplied by a sum or difference, remember to distribute the negative sign along with the number. So if I had 5 minus 2 parentheses x plus 3, what this is saying is don't forget to distribute that negative sign with the 2. So it becomes minus 2x, and then it becomes minus 6, and that 5 is still out front. On 4b, we need to distribute on both sides of the inequality sign. So we have 2h plus 12 is greater than negative 24 plus 3h. So again, that minus sign in front of the 3, the negative 3 gets distributed to negative h, making it positive 3h. So I'm going to choose to subtract 2h from both sides, leaving me with 12 is greater than negative 24 plus h. Add 24 to both sides, and I get 36 is greater than h, or h is less than 36. In solution set notation, that's h such that h is less than 36. If we were asked to graph it on a number line, which we are, I missed that on the last one, that would be an open circle at 36 with an arrow going to the left. Your number lines don't have to be too crazy, but just make sure that you have the number that you're actually graphing, in this case 36. Maybe put another couple reference points in there along the line, and you have your answer. I just want to quickly point out this note at the bottom of page 229. If solving an inequality results in a statement that is always true, the solution set is the set of all real numbers. The solution set is written as x such that x is a real number. If solving an inequality results in a statement that is never true, the solution set is the empty set, and that is written with the symbol here. The empty set has no members. To illustrate that, we can look at example 5. When we're solving an inequality, in this case we have to apply the distributive property, and we also have to combine like terms and get the variables on the same side. The result is 25 is less than or equal to negative 12, and that is not a true statement. The solution set is the empty set. In problem B, again, we have to distribute, and we do need to combine like terms and put the variable on one side. Our resulting answer is 18 is less than or equal to 18, which means that all real numbers will make this inequality true. And if you don't believe it, just check. Check any number you want for m and plug it in on both sides of the inequality and see if you don't come out with a true statement every single time. For 5a on page 300, we're going to distribute the negative 3. So we have 18 minus 24c minus 12 is greater than or equal to negative 24c plus 6. If we combine like terms, we have 18 minus 12, which is 6, minus 24c, greater than or equal to negative 24c minus 6. And there's really no point to go any further because what I have on both sides of the inequality sign are the same. So 5a is all real numbers. So the way I would write that in solution set notation is C such that C is a real number. On 5b, when I apply the distributive property, I get 46 is less than or equal to 8m minus 8m minus 20. And when I combine like terms here, I get 46 is less than or equal to 0m, or 0, minus 20. And 46 is not less than or equal to negative 20. So in this case, it's the empty set. No real numbers will make that statement true. I want to take a few minutes to look at the HOT, higher order thinking problems on page 302. Number 55 says, how could you solve this inequality without multiplying or dividing by a negative number? And right now we have negative 3p, so I'd have to divide by negative 3p to isolate it. But if I added 3p to both sides, what I'd have left is 7 is greater than or equal to 3p minus 2. And then if I add 2 to both sides, I get 9 is greater than or equal to 3p. And when I divide by 3, I get 3 is greater than or equal to p, which is p is less than or equal to 3. So that's how you can get around dividing by a negative and worrying about flipping that inequality symbol, as you could move things around a little bit. For 57, I'd like for you to try to solve each inequality for x. And if you want to pause the video and try those on your own, you can do that. If you'd like to work along with me, that's fine too. So in the case of letter A here, I have ax on the left and ax on the right. So the first thing I'm going to do is I'm going to add ax to both sides. So I have 1ax plus another ax, which is actually 2ax. I still have the plus 4, I still have the greater than or equal to sign, and I still have the negative 5. I'm going to minus 4 from both sides, and I get 2ax is greater than or equal to negative 9. Remember here that I'm trying to isolate the x, and so if I divide by 2a on both sides, divide by 2a, I get x is greater than or equal to negative 9 over 2a. In solution set notation, that would be x such that x is greater than or equal to negative 9 over 2a. In letter B, I'm going to start by getting the x's to the same side and adding ax to both sides. So what I have is 2 is less than x plus ax. Now since the x and the ax both have an x in common, I'm going to do a reverse distributive property, or I'm going to factor out the x, and what I'll have left is 1 plus a. Take a look at that for a second. I took an a out, I took an x out. What's x times 1? X. What's x times a? ax. So what I have is 2 is less than x times the quantity 1 plus a. And in order to isolate the variable x, I can divide both sides by 1 plus a. 1 plus a. So the final answer for B is 2 over 1 plus a is less than x, or we could write that as x such that x is greater than 2 over 1 plus a. On letter C, we have negative 2 over a x plus 3 is greater than negative 9. I'll subtract 3 first to get negative 2 over a times x is greater than negative 12. If I multiply by the reciprocal, a over negative 2, I can isolate the variable x, but I also need to remember to multiply the right side by a over negative 2, in which case I did multiply by a negative number, so the inequality sign flips. X is less than a over negative 2 times negative 12, which simplifies to 6a. So we have x such that x is less than 6a. Hopefully these higher order thinking problems take it to the next level of complexity for solving multi-step inequalities. Still the same things to pay attention to: multiplying and dividing by negatives, also working with the distributive property and making sure to distribute the negative signs, and then just paying attention to details. That's what really this is all about. So take your time, make sure you understand the homework, and ask if you have further questions.